In a dark control room lit only by cold monitors, the data on the screen has stopped behaving. A junior analyst rubs his eyes, reruns the model, and realizes the problem isn't the software. The problem is the universe. The most promising environments for life in our solar system are not planets. They are moons, frozen, distant, apparently dead. Worlds with oceans larger than all of Earth's combined. Worlds with atmospheres, storms. Rain is made of alien chemicals. Worlds that quietly satisfy every condition for habitability, while the planets they orbit are scorched, poisoned, or falling apart. If humanity ever finds life out there, there is a very real chance it will not be under a blue sky. It will be under miles of ice. In a black ocean that has never seen the sun. We treated moons like background objects. Tonight, you will find out what happens when the background turns out to be the main story. Alright, let's get into it. Number 10. Phobos, the moon that is falling to its death. Imagine standing on a world and watching its moon slowly die. Not to explode, not drift away, fall. Every single century, Mars' tiny moon Phobos moves roughly 6 feet closer to the planet below. That may not sound dramatic, but on astronomical timescales, it is a death sentence. Discovered in 1877 by American astronomer Asaph Hall, Phobos is one of the strangest objects in the solar system. It is only about 17 miles across, making it less a moon and more a captured cosmic boulder. Scientists still debate exactly how it formed. It may be a captured asteroid or debris blasted into orbit long ago. Unlike our moon, which is slowly moving away from Earth, Phobos orbits so close to Mars that tidal forces are dragging it inward. The process is slow, relentless, merciless. In roughly 30 to 50 million years, Phobos will either crash into Mars or be torn apart before impact. If it breaks apart first, the debris could briefly form a ring system around the red planet. It is like watching a clock whose hands move so slowly that entire civilizations rise and fall between each tick, but the countdown never stops. Phobos is a living laboratory for planetary evolution, a reminder that celestial systems are not permanent. They change, they decay, they die. The disturbing implication is that stability itself may be temporary. Even the skies above a planet can have an expiration date. Number 9. Callisto, the solar system's ancient memory. If planets keep records, Callisto keeps secrets. Orbiting Jupiter at more than 1 million miles, Callisto is one of the most heavily cratered worlds ever observed. Every impact, every collision, every scar remains visible for billions of years. While Earth constantly erases its past through erosion, oceans, plate tectonics, and weather, Callisto preserves it like a cosmic fossil. First observed by Galileo in 1610, it was transformed from a dim dot of light into a detailed world by NASA's Galileo spacecraft. Images revealed a landscape saturated with craters from horizon to horizon. There are places on Callisto that may not have changed significantly since the early solar system. The ancient solar system was violent. Worlds collided. Asteroids rained down. Entire surfaces were destroyed and rebuilt. Most of that evidence is gone. Callisto kept the receipts. Scientists believe an underground ocean may exist beneath its battered surface. If confirmed, it would mean that one of the oldest-looking worlds in the solar system still possesses hidden activity beneath its scars. Outside, Callisto appears dead. Inside, it may not be. It is like discovering that an abandoned cathedral still has a heartbeat beneath its stone floor. Callisto reminds us that appearances can be deceptive, and that the universe may be filled with worlds that seem lifeless only because we haven't looked deeply enough. Number 8. Ganymede, the moon bigger than a planet. Imagine discovering a moon so large that if it orbited the sun directly, we would call it a planet. That is Ganymede. Jupiter's largest moon is not merely the biggest moon in the solar system, it is larger than Mercury and larger than Pluto. Discovered by Galileo in 1610, Ganymede stretches more than 3,200 miles across. For decades, astronomers assumed moons were simple, small, inactive, secondary. Ganymede shattered that assumption. Data from spacecraft, including Galileo and observations from the Hubble Space Telescope, revealed a massive subsurface ocean hidden beneath layers of ice. Scientists estimate this ocean could contain more water than all of Earth's surface oceans combined. And then there is the magnetic field. As far as we know, Ganymede remains the only moon in the solar system with its own internally generated magnetosphere. Something inside is still active, still dynamic, still generating energy. It is like finding a small town that secretly contains the infrastructure of an entire nation. Everything about Ganymede challenges the old hierarchy of the solar system: planet, moon, primary, secondary. When a moon contains an ocean, a magnetic field, and a complex interior, it stops feeling like a side character. It has become a world, and perhaps one of the most important worlds we have ever properly visited. Number 7. Titan, the moon that looks uncomfortably like a planet. If you could somehow stand on Titan and survive the cold, the sky above would not feel like the sky of a moon. It would feel like a world, the real world. There is weather, seasons, clouds, rivers, lakes, and rain. The only problem is that none of those rivers contain water, none of those lakes contain water, and none of that rain is water. Everything is made of liquid methane and ethane. Titan, Saturn's largest moon, remains one of the most fascinating objects ever discovered. NASA's Cassini mission and the European Space Agency's Huygens probe revealed landscapes eerily like Earth beneath Titan's thick orange haze: coastlines, river channels, dunes stretching for hundreds of miles, and entire lake systems clustered near the poles. Scientists searched for another Earth-like environment and instead found an alien version of Earth operating with completely different chemistry. Titan is the only moon in the solar system with a dense atmosphere, thicker than Earth's, with surface pressure about 50% greater than sea level on our planet. Hidden beneath that atmosphere may be a vast subsurface ocean composed of water and ammonia. That combination makes Titan extraordinarily important. It is one of the few places where scientists can study complex organic chemistry on a planetary scale. The building blocks of life appear to be everywhere. Chemistry is active. The ingredients exist. Yet life, as we understand it, has never been confirmed there. It is like walking into a fully furnished house and finding nobody at home. The lights are on. The rooms are ready. Everything appears prepared for occupancy. Yet silence remains. If a moon can develop conditions this complex, this dynamic, and this planet-like, without being a planet, then perhaps habitability is not rare. Or perhaps the universe creates suitable environments everywhere, and life still fails to appear most of the time. Number 6. Enceladus, the moon that cannot stop leaking its secrets. Most worlds hide their oceans. Enceladus is different. It sprays them into space. Before the Cassini mission, Enceladus was considered relatively unremarkable, a small icy moon about 300 miles wide, one among dozens orbiting Saturn. Few expected it to become one of the most important astrobiological targets in human history. Then Cassini flew through enormous plumes erupting from the moon's south pole. These geysers were not tiny bursts of vapor, they were gigantic jets of water ice. Organic compounds, salts, and other materials blasted hundreds of miles above the surface. The spacecraft repeatedly sampled the material directly, effectively allowing scientists to study an alien ocean without drilling through miles of ice. Evidence pointed toward a global subsurface ocean beneath the frozen shell. More importantly, observations suggested hydrothermal activity on the ocean floor. On Earth, hydrothermal vents are among the most promising environments for the origin of life, providing heat, chemical energy, and stability in complete darkness. Enceladus possesses 3 ingredients scientists desperately look for: liquid water, energy, and organic chemistry, the holy trinity of habitability. Imagine a sealed vault buried beneath Antarctica. You cannot enter, you cannot see inside. Yet every few minutes, the vault ejects samples of its contents directly into your hands. That is essentially what Enceladus is doing. If life exists in Enceladus's ocean, it may not stay hidden forever. Future missions could detect biological signatures without ever landing, simply by flying through the plumes. Humanity could discover alien life not through a grand interstellar journey, but because a moon refused to keep its ocean buried. Number 5. Triton, the captured world. Every moon has a story. Triton's story is one of abduction. Orbiting Neptune nearly 3 billion miles from the Sun, Triton behaves differently from almost every large moon in the solar system. Most moons orbit their planets in the same direction that their planets rotate. Triton does the opposite. It moves backward. Astronomers call this a retrograde orbit, and it immediately suggests something extraordinary. Triton probably did not form alongside Neptune. It appears to be a captured object, likely originating in the distant Kuiper Belt, the frozen region that also contains Pluto. In other words, Triton may once have been an independent world, then Neptune stole it. That capture event would have been catastrophic. Gravitational forces likely heated Triton's interior, reshaping the moon and driving geological activity. Voyager 2 revealed nitrogen geysers erupting from its frozen surface, proof that the world is still strangely dynamic, despite temperatures around -391 degrees Fahrenheit. Something still moves. Something still changes. Some researchers suspect an ocean may even exist beneath the icy crust. Triton is not just important for what it is, but for what it represents. A reminder that planetary systems are chaotic. Worlds migrate. Objects collide. Moons are captured. Nothing guarantees permanence. It is like discovering that a member of your family was not born into the family at all, but was adopted during a violent event nobody remembers anymore. The solar system looks orderly because we are seeing the final chapter. Triton hints that the earlier chapters were far messier. Number 4. Earth's moon. The reason we may exist. Sometimes the most important moon is the one we stop noticing. The moon has hung over humanity's shoulder for so long that it feels ordinary. It appears in poetry, religion, mythology, calendars, and love stories. Yet scientifically, its existence may be one of the most important events in Earth's history. Current evidence suggests the moon formed about 4.5 billion years ago after a Mars-sized object, often called Theia, collided with the young Earth. The impact was unimaginably violent. Oceans of molten rock, debris blasted into orbit, a sky on fire. Eventually, that debris collapsed into the moon. Out of catastrophe came stability. Today, the moon acts as a gravitational anchor for Earth. Its presence helps stabilize our planet's axial tilt. Without that influence, Earth's rotation axis could vary dramatically over time, producing extreme climate shifts across geological timescales. In simple terms, the moon helps prevent your planet from becoming chaotic. It also drives ocean tides, shaping coastal ecosystems and potentially playing a role in the development of early life. Some researchers argue that tidal environments were important laboratories for prebiotic chemistry billions of years ago. Compared with most known planet-moon pairs, our moon is exceptionally large relative to its host planet. That may not be a coincidence. It may be part of the reason intelligent life had enough stability to evolve. Earth and the moon are linked in ways we rarely appreciate. The unsettling implication is that when humanity searches for habitable worlds elsewhere, we may need to search for the right moons as well. Perhaps planets do not create civilizations alone. Perhaps they need partners. Number 3. Europa. The ocean that never sees the sun. Imagine standing on a sheet of ice miles thick, knowing that beneath your feet lies an ocean larger than all of Earth's oceans combined. That is Europa. From a distance, Jupiter's moon appears smooth and quiet. Its bright surface is crossed by long reddish fractures that stretch for hundreds of miles. For decades, these strange patterns fascinated astronomers, but the real discovery was hidden underneath. Evidence from NASA's Galileo spacecraft strongly suggests a global liquid ocean beneath Europa's frozen shell. Scientists estimate this ocean may contain twice as much water as all of Earth's oceans combined. What makes Europa extraordinary is not just the water, it is the energy. Jupiter's immense gravity constantly squeezes and stretches the moon through tidal forces. This process generates internal heat, preventing the ocean from freezing solid despite the brutal cold of deep space. Some researchers believe hydrothermal activity may exist on the ocean floor, creating conditions similar to environments where life thrives on Earth. The terrifying part is how isolated that ocean is. No sunlight reaches it. No sunrise has ever illuminated its depths. If life exists there, it has evolved in complete darkness for billions of years. It is like discovering an entire ecosystem hidden beneath a frozen continent, cut off from the rest of reality before complex life appeared on Earth. If Europa is inhabited, even by microbes, one conclusion becomes difficult to avoid. Life may not need Earth-like planets nearly as much as we thought. Number 2. Exomoons. The worlds we can barely see. For thousands of years, humanity only knew the moons of our own solar system. Then we discovered exoplanets. Suddenly, the galaxy became crowded. Today, astronomers have confirmed thousands of planets orbiting distant stars. Some are larger than Jupiter, some are rocky worlds like Earth, some orbit 2 suns, others circle dead stars. But a bigger question remains: where are their moons? Scientists call them exomoons, and despite years of searching, they remain frustratingly difficult to detect. A few promising candidates have been reported, including a possible giant moon around the exoplanet Kepler 16225b, but no exomoon has been confirmed beyond all doubt. This uncertainty is probably not because exomoons are rare, but because they are incredibly hard to see. Detecting a distant planet is already challenging. Detecting a moon orbiting that planet is like trying to spot a firefly circling a lighthouse from thousands of miles away. Researchers keep searching because the implications are enormous. Many exomoons could be heated by tidal forces like Europa and Enceladus. Some may possess thick atmospheres. Others may orbit giant planets inside habitable zones around their stars. In theory, some exomoons could be more suitable for life than the planets they orbit. Humanity has spent decades searching for another Earth. What if the first truly habitable world we discover is not a planet at all? What if countless life-bearing environments are hiding in the shadows of giant worlds throughout the galaxy? The universe may contain an entire category of habitable worlds we have barely begun to detect, and that possibility changes everything. Number 1. A moon could be more habitable than a planet. For most of human history, planets were considered the ultimate destination. If life existed elsewhere, it would surely be on another planet. That assumption is starting to feel fragile. When scientists compare the most promising environments in the solar system, a pattern emerges. Some moons possess liquid water. Some have internal heat. Some have organic chemistry. Some have protective atmospheres. Some have remained stable for billions of years. In certain ways, they appear better protected than entire planets. A planet located inside a habitable zone can still become a wasteland. Venus may be the most dramatic example. It orbits in a region where liquid water might once have existed, yet today its surface is hot enough to melt lead. Habitability is not guaranteed. Distance from a star is not enough. What matters is stability. What matters is energy. What matters is chemistry. And many moons possess all three. Researchers have even proposed the concept of superhabitable worlds, environments that might support life more effectively than Earth itself. The idea is hypothetical, but it forces scientists to reconsider old assumptions about where life should emerge. The universe rarely cares about human categories: planet, moon, primary, secondary. Those labels exist because we created them. Nature does not. A moon orbiting a giant planet can host oceans, energy sources, atmospheric protection, and geological activity. If life can emerge under those conditions, then the distinction between moon and planet becomes far less important than we once believed. For centuries, humanity assumed planets were the stars of the story. Now we are beginning to suspect that some of the most important worlds in the universe may have been supporting characters all along. Tonight we traveled across the solar system and beyond, following a trail of worlds that most people rarely think about. We saw Phobos slowly falling toward destruction, Callisto preserving the scars of ancient chaos, and Ganymede blurring the line between moon and planet. We descended through Titan's thick atmosphere, flew through the water plumes of Enceladus, and studied Triton, a stolen world wandering far from its birthplace. Europa hinted at dark oceans filled with possibilities, and exomoons stretched that idea to a galactic scale. Maybe each moon on this list is simply another destination for future spacecraft. Or maybe they are clues. Clues that life is not confined to the narrow categories humanity once created. Clues that oceans can survive beneath ice, that habitability can emerge in places we once ignored. The disturbing possibility is that while we have spent generations searching for another Earth, life may have been hiding somewhere else entirely. Not on planets, not under blue skies, but beneath frozen crusts, inside dark oceans, orbiting giant worlds in the cold silence of space. The universe may not be empty. We may simply be looking in the wrong place. Sleep well. If these questions keep you up at night the way they keep us up, you already know where to find more. Subscribe to Astro Buddy. We'll be here, in the dark, waiting.